All right, hey everyone. How's everyone doing tonight? Good? Good.
Great.
Thank you. All right, so thank you everyone for coming out to our second general body meeting of this year. We have a special guest here today, HMB Software, all the way from Columbus, Ohio. Yes. And this is also a joint meeting with ACMW. So that's really cool.
Wave ACMW.
Wave ACMW. Cool. So
there's only 3 ACMWs.
there should be more. So before we get started, I just wanted Amber and Brett to quickly introduce themselves and the company that they are representing. And their website, by the way, is right here. And while you're listening, you might want to also do attendance. So go ahead, take it away, Amber.
Yeah, hi everyone. My name's Amber Rush. I'm a recruiter for HMB. We're in Columbus, like Noah said. We're a software development firm. The main thing we do is build custom applications for our clients that are all also in Columbus. So we do consulting. So really when our clients can't find something off the shelf or out of the box, we can create those custom business solutions for them. All of our clients are in the Columbus area as well, so it's working with literally any sort of industry you can think of, whether it's a retail company or healthcare or manufacturing. At some point, we've probably touched most of them, but we'll put together the full team of consultants to send to a client site to create whatever the custom application is that they need. We are around 260 in size at this point, most of which are consultants. So in our main office, there's probably 30 to 40 more internal staff, and then the rest of the folks are all consultants working out of different client sites in the Columbus area. So we'll stick you on teams, you're on the client site for the duration of that project, and then you come back to the office and you're on the bench in the meantime. And during that downtime, we really just focus on trainings and certifications and continued education. We actually have a group internally called HMB University, and they're responsible for all the curriculum. So always a ton of learning continuing to happen throughout your career. I think really a career in consulting is an awesome route to go if you're really passionate about technology, which I'm sure most of you are since you chose this as a career, because you get to do different stuff all the time, always working on different projects with different sorts of industries and not just stuck doing the same thing day after day like you might in a corporate environment. We have a cool program called Grad Academy that we do each June for our new grad hires that we bring in. It's a 3-week intensive training program, kind of a crash course, learn everything you didn't learn in the classroom type of program, help you prepare to then go to client sites and start working on projects. So that's really what we're looking to hire for 2019. So if anyone is graduating this spring and interested in chatting more, I actually put a sign-up sheet down here. So I'm staying tonight to meet with some students tomorrow. I have 3 more slots open. If anyone is interested in meeting for coffee tomorrow to chat a little more, please feel free to sign up on this sheet right here. Or if you don't have time tomorrow, but you're still interested, my cards are down here. And I'm going to pass around a little sign-in sheet if you all would just put your info on it. I would love to send a follow-up to everyone so then you have more info about HMB if you want it in the future. But that's kind of an overview of who we are in general. This is my very first time ever on campus at UC. I do all of our college recruiting, but we've never recruited from UC before. So I'm very happy to be here and meet you all and see such a great turnout. So yeah, we'll have Brett come introduce himself. He's actually one of our consultants. He went through our grad academy 3 years ago. 3 years ago. So yeah, he went through grad academy and here he is 3 years later. And so he's gonna tell you guys some really cool stuff about blockchain.
Nice. Thanks, Amber.
Just introduce yourself and your background to everybody.
Yeah, so I have this in a slide, but I can...
Okay, we'll get to that in a bit.
Sounds good.
Yeah.
So my name is Brett, like Amber said. Amber did a very good job telling you about HMB. I am a Buckeye. I graduated from Ohio State, unfortunately. But I graduated...
Go Bucks!
I didn't know if I could say that. But I graduated in computer science and engineering. Been with HMB for just over 3.5 years. Like Amber said, went through grad academy with 10 or 11 other people. It's an awesome opportunity because like some companies will just throw you at a client site, expect you to start performing. It gives you a chance to learn all the technologies that we expect you to know or hope you have touched before. And it starts from HTML and then goes through like creating a web API. And at the end, you have a full web app that you can deploy to the cloud and stuff like that. So there's some pretty fun stuff. It gives you a chance. It's taught by our consultants. So this last year, I taught a day on Angular, if any of you guys are familiar with the Angular framework. So right now I live a lot in the JavaScript world. For any front-end savvy people, I'm at a energy client. I've been at 6 different clients now. And like Amber said, I think for me, one of the things that sold me on consulting coming out of college was just that I had no idea what I wanted to do. And consulting has given me the opportunity to touch everything from the very back end of systems to right now living a lot in JavaScript. You see how a lot of different teams interact. You see how you work better in different environments and stuff. And so just really enjoyed working for HMB. So.
Okay, cool. So we have a few ACM and ACMW general updates. First of all, you're being recorded. There's a camera up there. You can find all of our recordings, slides, all that stuff at acmuc.org/archive. And our org calendar is at acmuc.org/meetings. And also we have a listserv for all event notifications. If you sign into today's meeting using that link, you will be automatically added to it. So what does ACM at UC do? Well, we do bi-weekly meetings. You're in one right now with tech talks and workshops. We also host social events. Revolution UC, the student hackathon at UC. Make UC, another student hackathon at UC happening late this September. You can read more about it at makeuc.io. ICPC, the International Collegiate Programming Contest, tons of review sessions, office hours, and of course our Slack group. You can sign up if you're not on there at acmcincy.slack.com. So ACMW, Monty, you want to come up?
Yeah, Tessa as well. So we're from ACMW, and basically our purpose is to increase the recruitment and retention of women in computing at UC. So when we first started, the percentage of women in computing was very, very tiny, and now it's up to 12.8%, which is fantastic. ACMW offers UC students different activities, projects, and access to events. So we do host a lot of events in conjunction with other clubs. So Tessa is also president of WIT. And our aim is basically to improve the working and learning environment for women in computing. So we're a women in computing organization, and many of you are men in here. Can you be involved in ACMW? And the answer is absolutely yes. And I'm sure the recruiters here can attest to that. Seeing men involved in supporting women in computing and women organizations is a huge boost to your resume as well, and to who you are as a person and who we are as a generation. So some other things that we do is we host a Bearcat Coders volunteer program with Hughes High School. So Tessa will talk a little bit more about that.
Yeah, so if you're not aware, Hughes High School is like literally right across the street. And what we do is we go in and we help them with their technology classes. So anything from like a very basic intro to like a college level class. So if you're a Cincinnati Scholar or Turner Scholar, or you need some sort of service hours, that's an awesome way to get involved and to give back to the community as well. If you're interested in learning more about that, we do have like training slides and forms you need to fill out because you are volunteering at a high school. You can go to our website, acmwuc.org/activities.
Yep. And if you guys have any questions about how to volunteer, where to volunteer, another exec, Siley, will be here towards the end of the meeting to answer any of your questions as well. All right. Thank you.
Cool. Thanks, Monty. Thanks, Tessa. Yep. Okay, so you all are probably aware of our code of conduct. You can find it at acmuc.org/conduct. And also, please follow the UC code of conduct as well. So our Slack is at acmcincy.slack.com. It is the best way to connect with other people in this community. So there's tons of channels in there, like random off topic, homework help. You can post anything you want as long as it abides with the code of conduct. And there's desktop and mobile apps available, so you can take it wherever you go. Make UC is our student hackathon, kind of like a mini hackathon happening on September 29th. You can read more about it at makeuc.io. So it's just a 12-hour mini hackathon. Software and hardware projects are totally cool. Our sponsors include Marathon, 8451, UC Student Gov, ACM, and IEEE. So space is super limited for this. So if you're interested, I advise you go to makeuc.io right now. So that brings us to a talk on blockchain. Brett, take it away.
Sure. Let me see if how quick did you see this one? We'll cross that bridge when we come to it. Nice. Well, thanks for having me, guys. I'm really excited to be here. Admittedly, I don't know very much about UC. I know you guys have some sort of cheer where you do like a oh thing, and that's about it. But yeah, thanks for having me. We're going to be talking about blockchain and is it worth more than a Bitcoin? So this is really a talk about, a lot of people have heard buzz about blockchain, but is there actual value for it in the marketplace in the long term? So before we get started, can you guys just hold up a 1 to 5, 1 being I've heard of Bitcoin and 5 is I can put something on the blockchain right now if you ask me to. Nice. I gave this talk one other time and a guy held up a 5 and I asked him if he wanted to switch spots because that's higher than me, so. Nice. Real fast, you guys are all doing a great job by being here. I've never gotten to talk to college students before, but if I had one tip for getting a job after school, it would be to be a learner. Sometimes I talk to people in college that don't know what HTML or CSS are. If you don't know what those are, I suggest just take an hour for each of the things listed up here and learn them because you're going to get asked something regarding those in every interview that you do. And it just shows that you're excited about the technology that you're looking into and that you're ready to learn when you get to your job. So if the rest of my talk is terrible, just remember to try to be a learner. So why blockchain? If you're like me, your friends and family know that you do something where you look at your computer a lot, you write code, so you've probably been getting texts like this one. This is one of my good buddies, right? He says, I know you're on your days, but have you invested in cryptocurrencies? He knows that I'm with my wife, but this is a pressing question. There's a lot of reason for this though, right? Last year, November, December timeline, the price of Bitcoin absolutely skyrocketed. We saw it go from $2,000 all the way up to past $20,000. At that time, there was speculation that maybe it would hit $40,000. This one company, I don't know if you guys heard about this, but Long Island Iced Tea changed their name to Long Blockchain, and their stock tripled overnight. So the hype is there, but is there long-term value? So why me? The truth is I've never invested in a cryptocurrency. It seemed a little weird that I'm up here talking to you about Bitcoin and blockchain. I've never mined any Bitcoin and I don't have any dApps in production. But in preparation for this talk, I did spend more than 100 hours researching blockchain. I got to talk to multiple companies who are implementing blockchain solutions. HMB is actually in the early phases. Don't take this back to the office because I want this back down to reps. But we're in the early phases of talking about blockchain and how we can get involved. I put a node on the Ethereum blockchain, and then I deployed a dApp to a private blockchain, which you'll get to see at the end of my presentation as a practice. So who am I? I covered most of this stuff already. That's one of my email addresses. Feel free to email me if you have any questions about this or about HMB in general. I also have business cards up here with my HMB email address, so I'm happy to talk about that. We also have a small office in Louisville that has not nearly as many people as in Columbus, but I think we're trying to grow that office as well.
We are. I'm sorry, I didn't even mention that. I forgot about our poor little Louisville office.
Yeah.
We've got 15 folks in Louisville, and obviously you guys are kind of in the middle of Columbus and Louisville, so both could be of interest, but we actually are looking to hire a couple of grads for Grad Academy that will then work in Louisville as well, if that's an interest for anyone.
Yeah. So I've been with HMB a little over 3 years. This is usually where I give my HMB pitch, but I already gave that, so I'll skip that. I also have been married for a little over 3 years, and I actually got married the weekend before grad academy, so I missed the first week of our 3-week grad academy, but I came back for the last 2 weeks, and it was awesome. So when I was getting ready for this talk, I asked my wife, I said, these guys aren't going to know much about me. What's a fun fact where I could get them to laugh? And she said, you're married to me? And I said, I am. I think sensing the hesitancy in my voice, she said, what, is that not fun enough? And I said, no, it's a blast. So last fact, I have the best wife ever. So,
Does she know that you say this because I need to record it?
I did inform her, yeah. So a quick disclaimer before we get started, I'm not endorsing Bitcoin or other cryptocurrencies as an investment strategy. Right now, Andreas Antonopoulos, who's one of the leading advocates for Bitcoin, thinks it still has 3 to 4 boom and bust cycles left in it. And so that's a little too fluid for, my wife and I are trying to buy a house, so I can't be invested in fluid cryptocurrency. But if you have a different point of view and want to try to convince me afterwards, you are more than welcome to try. So if we think back to that graph I showed a couple slides ago, it's a pretty surprising curve, right? What Bitcoin's price did late November or December of last year, but it's nothing new. And that's why Gartner came up with a term for that curve. So Gartner is a research firm that does market analysis on different industries. So they have this chart that they put out every year called the Gartner Hype Cycle for Emerging Technologies. This one's from 2017, slightly old slide deck because my MacBook crashed earlier this week, so my updated slides were lost, but I luckily had this on my Google Drive. So for 2018, it's pretty much in the same spot, but you'll see that blockchain is right up here, coming off the peak of inflated expectation, almost into the trough of disillusionment. And so for my talk today, what I want to do is follow this exact trajectory. So I'm going to take you up the innovation trigger, which is where I'll be describing how blockchain works and what it is, up to the peak of inflated expectations, where I'll kind of be talking about all the different industries that blockchain is affecting. Through the trough of disillusionment, where I talk about why blockchain isn't always a great solution and some of the problems that we've ran into with it. And then up through the slope of enlightenment, which is where I'm going to show you like the good use cases for blockchain, and also a quick demo about how you can deploy a dApp. And then I'm going to leave you at the plateau of productivity, which is where I hopefully usher you out of this room and you're ready to be productive and deploy a dApp to the blockchain instance. So we're going to make a couple of quick assumptions from the start, which is one, that we all know what a cryptographic hash function is. If you don't, that may seem like a large assumption to make. There's just 2 things you need to know about it. One is that it performs extremely efficiently. The second is that even for the smallest change in its input, it will give you a vastly different and unrelated output. And the second assumption is that we all know that Bitcoin is not blockchain. Bitcoin is simply one implementation of blockchain, but saying that Bitcoin is blockchain is like saying, I don't know what technologies you guys are familiar with, but it's kind of like saying React is JavaScript. So React is one implementation of JavaScript, but JavaScript as a whole has a lot more implementations that are being used effectively throughout the marketplace. So I don't know what image comes to your mind when I say Bitcoin and blockchain, but for me about a year ago, it was this picture on the right-hand side of the slide with a gold coin and people mysteriously making money overnight. So that myth was kind of debunked about a year ago. Like I said, when I went on a vacation with a buddy of mine, that buddy works for a pretty conservative company in a traditionally conservative industry that is not banking. And when he said that his company was looking at blockchain solutions for some of the problems they were facing, I thought this thing has to be bigger than just cryptocurrency. So when I got home from that trip, I started looking into it. As I started looking into it, I started reading a lot about the medical space. And I have 3 people in my life that I'm really close to that are in healthcare. One is my mom, who's a nurse. One is my brother, who's in med school at Ohio State, and the other is my buddy, who's in med school at Vanderbilt. Late last winter, I was talking to my buddy that goes to Vanderbilt on the phone, and he said that he was spending 1 to 2 hours a day just calling other doctors' offices, trying to get patient records for the patients they were going to see that day. that's when I immediately Googled how much Vanderbilt's tuition was to see how much those phone calls were costing. And they are not cheap phone calls. Last is, so as I was researching this medical space, something that blockchain has the potential to impact heavily is whether EMRs, or what's known as electronic medical records. So that industry in 2016 was estimated about $28 billion. So even if blockchain can grab a portion of that $28 billion, you can see how it's going to be a significantly disruptive technology. What I say electronic medical records, so that's a mouthful, is if you and I go to a hospital or different doctor's offices, and my name is Brett, so I have 2 T's at the end of my name. Maybe one doctor had it messed up and it's Brett with 1 T, the other doctor has Brett with 2 T's. There's no way that those are getting correlated, even if the doctors do talk, which frequently they don't do. I've moved around, I've gone to different specialists, so there's no one doctor I can go to that has all of my medical history through time to make a super informed decision. I want to carry this EMR example throughout the rest of my talk. So if you guys have this example in the back of your head and are kind of spinning your brain on like how this could be impacted with blockchain, that would be great to think about, so I'll come back to it multiple times. So what is blockchain? Probably the most unhelpful analogy I heard was by a guy named Don Tapscott, who's the co-founder of the Blockchain Research Institute. What he said was that blockchain is like a chicken McNugget. And if you wanted to hack it, it would be like trying to turn a chicken McNugget back into a chicken. For me, that analogy did absolutely nothing. So what I think a better definition is the definition at the bottom of the slide there. Blockchain is a persistent, transparent, public, dependent ledger. Now this is nothing novel, it's just a conglomeration of what you'll find if you Google what is blockchain, click on the first couple links. But for me, this was really helpful to frame it. So blockchain kind of came about as a solution to what's known as the Byzantine general problem, which is a problem that's been around in computer science for 50 or 60 years. And blockchain helps to solve that problem. Now I throw out Byzantine general problem, which is something that probably not a lot of us are familiar with. However, something that a lot of us are familiar with is Excel. So the easiest way to think about blockchain is like a spreadsheet where each row has a reference to the previous row. Again, if you Google blockchain, what is blockchain, you would find stuff from Don Tapscott that's not helpful. If you searched on YouTube, you would find videos. One video I found had a guy with shoe boxes. He was slipping pieces of paper in different shoe boxes and shuffling them around. I watched the 10-minute video and I was like, I am no better informed than I was at the beginning of this. So I tried to come up with a better graphic. So hopefully this does a little bit better job of explaining it. This all starts in the top left. In my EMR example, you can imagine that this is the doctor sitting at his computer in the doctor's office, entering patient notes, prescriptions, diagnoses, things like that. Each one of those comes in as a transaction, or you could think of it as like a post request if you're familiar with more traditional REST APIs. Those go into what's known as a transaction pool. In that transaction pool, they're simply being weighted on a block to pick them up and group them together. Once a block comes and picks them up, they're put into what's known as consensus work. Now that consensus work box up there is intentionally a black box because for me, this is the hardest part of blockchain for me to wrap my head around. What's happening in that black box is some computers are looking for a random integer known as a nonce that will make this block a valid block. Once they find what's known as a valid nonce to create this valid block, it's put on this computer, like the computer that finds its blockchain, and then communicated out to the rest of the nodes in the network. Now let me dive in a little bit deeper because you might have thought that I just glossed over consensus work a little quickly after saying it's the most complicated part. When you're like me and you stare, I don't know how much homework you guys have, but I'm working on code close to 40 hours a week right now. So sometimes when you look at code for 40 hours a week, the easiest way to describe a problem is in pseudocode. And so for me, this made a lot of sense. So what's happening in that consensus work? Well, we're looking for a nonce, and as you can see there, I'm just kind of guessing randomly. Now, if you think back to what I said about a cryptographic hash function, there is no more of an intelligent way that these nodes can guess that nonce than to do it randomly, because as I said, each tiny difference in the input creates a significantly different and unrelated output. So it has no way to kind of like trend towards a better answer. It's just guessing randomly. It passes that to the function to generate the hash and then test if that's a valid hash. Now, for my example, what I'm saying is a valid hash is a hash that starts with 4 leading zeros. And every implementation of the blockchain, the hash is going to have a different definition of what makes it a valid hash. But for our example today, we're going to say any valid hash is a hash that starts with 4 leading zeros. If that nonce produces a hash that starts with 4 leading zeros, it then validates that block, which is where it sends that nonce and that block to the other nodes in the network, who also validate if they get that valid hash value, given that nonce value for that block of transactions. If it's not a valid one, it goes back, gets another random nonce, passes it to the generate hash function again, and then checks if it's a valid hash again. It repeats this until it finds a valid hash. Hopefully this is clear. If not, I'm going to flesh it out more as I go. So, if you guys weren't sure, the more common term for consensus work is what's known as mining. So, is anybody in this room a miner or have one? Nice. You guys have? Are you doing it on UC's Wi-Fi? I was going to say they might not be too happy about that. But yeah, we're going to jump into what mining is as we leave the innovation trigger and go up to the peak of inflated expectations. So what's actually happening when you're mining is you're working on that consensus work algorithm. In both the Bitcoin implementation of blockchain and the Ethereum implementation, that's what's known as the proof of work algorithm. This consensus algorithm has to be hard to solve but easy to validate. It's got to be hard to solve so that no one node in the system is more consistently getting that hash value first than any other node in the system. We kind of want the solution to come from different places in the network every time, or as much as possible. That is a benefit, one of the benefits of blockchain being distributed. It's got to be easy to validate, because if one node or computer in the network finds that valid nonce and passes it to other nodes in the network, we don't want those other nodes to have to spend all the compute time that they just spent trying to guess another random value until they find if it's correct. We want them to easily be able to validate that given this set of inputs, it will produce a valid output. So, as I said, the Bitcoin and Ethereum implementations of blockchain right now are both using what's known as the proof of work consensus algorithm, but there's a couple problems with it. One is that it wastes a lot of energy. Every node in the network that isn't the one that finds that valid nonce has just wasted all the compute power that they used guessing those random numbers. And second, like me sitting at home with my Lenovo Carbon is not going to compete with somebody that has the hardware of like a mega computer sitting, there's a thing called OCLC in Columbus. I'm not sure if you guys have anything similar, but it's essentially a supercomputer. So if they threw all their resources at solving that hash algorithm and I threw all my resources at it, they would just be able to guess those random values so much quicker that they're going to solve the problem much more quicker than I am and more frequently. So there's an alternative consensus algorithm that's starting to gain popularity, especially in the Ethereum space. Ethereum's probably going to fork over to this algorithm pretty soon, but it's called proof of stake. What happens in proof of stake is if you and I want to mine, we put a down payment of some cryptocurrency and to join a pool. Once you put down that down payment, you're put in this pool of other miners, and then the obligation to solve for that random value is randomly assigned throughout that pool. If you get the chance to solve it, and you solve it correctly, you're rewarded with more cryptocurrency. If you solve it incorrectly, that down payment is taken from you, and you're kicked out of the pool and can no longer solve it. So this kind of gives more the common man the opportunity to participate in mining and be rewarded. And it's one implementation that Ethereum is looking at. If you're interested in this there's a Wikipedia article that has like 10 different consensus algorithm proposals that you can research and look more into. There's a lot of interesting stuff here around game theory. So how does like these pieces of hardware guessing some random number work together? I'm going to get into the infrastructure of that now. I'm going to take a bottoms-up approach. So from the bottom, blockchain is built of transactions. So what is a transaction? A transaction is huge, and it could be an hour talk in and of itself. When I say it's huge, I don't mean data-wise, like it's like gigabytes of data or anything like that. I just mean there's a large variation in the space of what a transaction exactly is. So if we think back to my EMR example, each transaction would be each time I go to a doctor's office. So a transaction is just a representation of a change of state. So if you think about from the time I'm born, if that's put on the blockchain, and then I go for my 2-week checkup, that's put on it. Each of these would stack up together until the time now where I'm 25 years old and a doctor could see my whole medical record throughout time at any point in history. These are all propagated through the network using a peer-to-peer protocol once they're picked up in blocks. So what is a block? A block is just a data structure. I'm sure you guys have all worked in data structures with whatever language. What language does UC teach? Is it Java or C++? So yeah, maybe structs and pointers are more up your guys' alley. So blocks are just data structures. So they all have these groups of transactions, and then they have the nonce, which is the random integer that makes it a valid block. They have the hash, and then they have the hash of the previous block, which is what ties all these blocks in together as a blockchain. So here's a short video example. Hopefully this brings some more clarity to the nonce concept. You'll see right now, this is a valid hash because it starts with 4 leading zeros, and there's no data in it. As soon as I start typing data, this hash value changes each time I type a new character, and this needs to be remined to look for that new nonce that makes this have 4 leading zeros. So you'll see that this nonce value changes once I click mine. It now has 4 leading zeros, and that is a valid hash. So this becomes a valid block. As I said, each block holds a reference to the previous block. Just like in the spreadsheet, each row has a reference to the previous row. This is what ties together and gives blockchain that immutability principle, which is one of its biggest strengths. So blockchain is just a series of blocks. It starts with a genesis block, which is created by the person that starts that implementation of blockchain. So for Bitcoin, it was Satoshi Nakamoto. And then from there, they just reference one after another. Each node in the network has an entire copy of the blockchain on it. So if we jump back to our video, this is kind of what a blockchain looks like. So you'll see now, each block in the blockchain is valid. And here, each block in the blockchain has the reference to the previous block. However, if I type in the first block, it makes every block thereafter invalid because it changes the hash of the first one, which changes the hash of the second one, so on and so forth. So to change the data in the first one, you would have to go back and remine the entire blockchain. As the blockchain is stored on every node in the network, this is something that makes it really tough to do anything like this, like going back and changing data in the past, which is why it said that blockchain is immutable. So what does the blockchain sit on? What's the infrastructure behind it? I've been throwing out the term node a lot. A node is just a computer with a copy of a blockchain. So if you're sitting out there and you have enough space on your hard drive to download a client to join Bitcoin, your laptop could become a node. All these nodes are competitively cooperative. What I mean by that is they're all fighting to find that random number and solve the hash problem first. But once one suggests a valid answer, they all are cooperative together to validate that that is a true result. So it's really, as I said before, it's an interesting study on game theory, how these are all fighting together because they all want to win the reward of more cryptocurrency, but then they all work together to say, yeah, that's legit, we'll accept it. And then the network is pretty self-explanatory. It's just the network of all the nodes. So how does a new node join the network? Well, first you would download a client, and your node would start to look for neighboring nodes. Once it finds neighboring nodes, it starts to receive copies of the entire blockchain from those neighboring nodes. And then it starts validating every previous transaction. It needs to validate every transaction on the blockchain to ensure that the copy it just received isn't from like one bad actor trying to hack it and get more power in the network. So it goes through literally from the Genesis block and runs every transaction that's been running on that implementation of blockchain up until the current moment, and it gets the state of what it looks like at that current moment. So I've thrown out a lot of terms to you guys, nodes, nonces, hashes. How does all this come together? What's the benefit? Well, in Satoshi Nakamoto's white paper, they outline two major benefits. This is the line that he wrote in his white paper, and it's pretty easy to see in the banking example, right? If you're selling a house and I want to buy a house, I don't just go to you and pay you a couple $100,000 for that house. We go through a bank, right? So there's a middleman. The bank pays you, I pay the bank, we're all happy. In my EMR example, this is the same thing. Millions of dollars of that portion that I showed earlier are spent each year on different EMR systems translating or mapping data from this format that they understand to a format that they can either post to some external API or send to some other EMR. And this is no joke. In the hospital my mom works on, they have two different EMR systems on two different floors. So they need to map that data if one patient goes from one floor to the next. They need something to map it in between. If both of those systems are pulling from the blockchain and committing back to the blockchain, we can eliminate that middleman and they can talk directly with one another. The second is the double spend problem. I'm going to step away from the EMR example really fast and go to the finance example because it's pretty obvious. But if two of you guys thought that this talk was good at the end of it and asked me for a copy of the slides, I would have no problem going home, giving you an email with an attachment, with a PDF attachment of the slides at the end. You guys could both receive that attachment, download it on your computer, open it up, and both be happy. With a dollar bill, this doesn't work exactly the same way. You can imagine if I sent $1 to two of you guys, the first person to use it would be happy. The second person to use it would be very sad, because it wouldn't be an actual dollar. It would be probably some sort of scanned copy or something like that. In blockchain, this literally cannot happen, because before I sent that second copy of the dollar, it would see every previous transaction and know that I don't have $2 to give. I only have $1 and I already set that off. So what are some other benefits? One is that it's decentralized, there's no single point of failure. I made this point with how there are many nodes in the network. So if one node goes down, that's no problem. The rest of the network continues to function as normal. When that node comes back up after it was hacked or blew up or whatever the case may be, it can rejoin the network, download the copy of the blockchain, like nothing ever happened. The second is immutability. I kind of showed this in that video that I showed of how blockchain works, where if you would modify one block earlier in the blockchain, you would have to go back and recalculate every block thereafter. To do that, you would have to have 51% of the CPU power in the network. In late March, to get 51% of Bitcoin's network, it was estimated at just over $7.5 billion. So it's not impossible to do, but it was highly unlikely that somebody's going to get $7.5 billion. That number is only growing as more nodes join the network. Third is it has cryptography, asymmetric cryptography to be exact. This makes it hard to fake your identity. The best real-world analogy I could come up with is if there's any football fans in the room, you've seen on TV backup quarterbacks or whoever on the sideline hold up signs that look like that in the top right corner. We all know what a bridge, a tree, a Batman logo, and the Superman logo are, but we have no idea what that combination means to the team on the field. This is like your public key in blockchain. Everybody knows what the series of letters and numbers are, but nobody knows what that actually ties to. In my football analogy, the private key would be the knowledge that the team gained on the field in practice this week. So the quarterback sees this sign, he knows exactly what that means. In the same way, that's tied to your private key on your local hard drive. Last is the social impact. Now this point is huge, and I didn't want to make it the last bullet, but it doesn't tie super well into my EMR example. But if you think about it, right now there are 2 billion adults in the world without access to formal financial services in a lot of countries, in a lot of third world countries. With blockchain and simple internet access, we could give these adults access to services such as insurance, loans, bank accounts, without having to have a brick and mortar infrastructure reach them, which is a lot cheaper and quicker way to get to these people. So what industries is this affecting? It's affecting companies large to small. So I have some up here that are huge, like Barclays and FedEx, for example. I don't know what kind of companies you guys are interested in going to, but then I have some startups here like that you might not have heard of. I'm not as familiar with the scene in Cincinnati, but in Columbus, there are more than 5 startups that are trying to do stuff with blockchain. If you actually look into it, this is a very exciting time to be talking about blockchain in Ohio. The government just said that Ohio is a blockchain state, so nobody knows what that means really. But we are trying to attract talent from the coast to come here and work on blockchain stuff, and the government has the money that they are trying to give to people to work on blockchain stuff. Last week, actually, there's a company in Columbus called SafeChain that successfully, so the Secretary of the Treasury had a deed sale, which is kind of where they, I'm not exactly sure what they do, but something with land and property around the state, and they successfully committed that to a blockchain implementation. So it's a kind of exciting win for blockchain, especially in the wake of whatever the government announcement means. But you may say, hey Brett, I'll never work for a startup. I'm not going to be that risky. They can just shift on a dime. And I'm never going to work for some big company where I'm just like a cog in the system. So can you bring it down to my level? So I tried to find a couple examples of mid-sized companies that are doing this. Now, we could argue on if they're actual mid-sized or if they're large, but like the small to mid-sized don't get a ton of PR, so it's tough to find stuff on. So bear with me. But the first one is Kodak. Kodak is working on a system called Kodak One, which is going to allow photographers and artists to put their artwork on the blockchain and then manage the digital rights and access to those photos by being purchased, instead of somebody just going to their website, copying and pasting it into a presentation and hoping that nobody from Kodak ever sees that photo or whatever it wants their money. Next is Walmart. In partnership with IBM, Walmart implemented a blockchain solution to track their beef products across China, and they reduced the time that it takes to track those beef products from weeks to minutes. Why is this important? Well, in a day and age where farm to table is all the rage of restaurants, when you can prove exactly where your beef products were, how long ago they were farmed or harvested, what temperature they were stored at all times, this is a huge and tremendous advantage. Last is LLB. Now, if anybody in this room knows anybody that works in IT for LLB, I would love for you to get me in contact with them because I'm not convinced that they need blockchain for this. They are embedding IoT sensors in some of their outerwear, and then for some reason or another, they're going to transmit that data back to the blockchain. I don't know why, but I know what they're trying to do with that data is pretty cool. They're trying to track like how often their clothes are worn and in what temperatures and stuff like that. So I think that's cool, but I think blockchain is more just a buzzword for them. So why wouldn't you use it? I talked about how a couple of real-world companies are using it, talked about the benefits. Seems great, right? But why not? What are the negatives? So the downside are there's a lot of technical barriers, right? It takes time. It takes time for people like you and I to sit down at our computers and really convince ourselves of how this works. I spent over 100 hours on it, and I don't think I have it nailed perfectly. I have a better understanding of it than I did when I started. And it also takes time for companies to be willing to kind of shift towards this. And there are a lack of resources. There's a lack of resources both technically. So if you became a blockchain expert today, I would bet that you would not have a problem getting a job when you graduate. But there's also a lack of resources available on the internet, so it's hard to become an expert. If you search what is blockchain on the internet, you're going to find not a lot of original content and a lot of regurgitated articles with a lot of plagiarism, to be honest. The next problem is key management. So we have this problem of stealing private keys, right? If something on the blockchain is attributed to you, it's not attributed to like me, Brett Koenig, it's attributed to the private key that's associated with me. If somebody gets a hold of that private key, they just have access to all of my stuff that's been attributed to me. So if I leave my computer unlocked and somebody, I mean, this is a far-fetched example, but like if I walked out of the room, you guys walked up here and knew that I was mining on this, you could find my private key and gain access to all the cryptocurrency that I own. Additionally, if that hard drive with that private key on it went down and wasn't backed up, or if it caught on fire or was flooded or anything like that, and you didn't have that private key backed up, you would lose access to every asset that had been previously attributed to you. This is why you heard people going around looking for hard drives in dumpsters and in dumps when Bitcoin's price skyrocketed last year. Because if you had 1 or 2 Bitcoin, that was $20,000 to $30,000 on that hard drive. The last is scalability. So if we think about my EMR example, I found a stat that said every American adult had on average 3.1 doctor's appointments last year. If you multiply that out, it equals roughly 1 billion doctor's appointments. So if we think about all that data coming in as transactions, blockchain has to work pretty quickly. Right now, the Bitcoin implementation of blockchain processes roughly 7 transactions per second. Visa processes roughly 500 times that amount. So if this thing is really going to scale, we have some speed and improvements to come up with. And the second is no hardware space. Earlier this summer, the Bitcoin implementation of blockchain was over 150 gigs. I think it's over 200 now. I'm not positive on that. But you can see this is going to quickly eliminate the little guy from being able to log on at home with his laptop because you and I don't have 200 gigs of hardware space and growing just to give to this process. So there's a couple problems that we need to figure out there. But when would you use blockchain? So a couple bad use cases. The first is Snapchat. If you guys remember back to when Snapchat started, it was meant to be a picture sharing service where those pictures were gone as soon as the receiver saw them. With blockchain, that's impossible, right? They would be out there forever. This is a terrible use of blockchain. The second is a to-do list app. If you're like me, 6 months from now, you won't care about the homework assignments that you have today. As a matter of fact, you'll probably be glad that you forgot about them. You won't want to go back and check what you were doing 6 months ago. So there's no need for the blockchain. Third is your company's intranet. So at HMB we have an intranet. It works great. It's like for company announcements, time tracking, billing, stuff like that, expense tracking. We're not sharing data. We own all that data internally to HMB. We don't want to share that externally. We have no need for blockchain in that situation. So what are the good use cases? In my opinion, there's 2 good use cases for blockchain. One is when you want to track entities over time, and the other is sharing data across organizations. Tracking entities over time is beneficial because it's auditable. Imagine if you worked for a huge company and you had one of the big 4 accounting firms come in and you could say, hey, here's every expense that we've had over the last year. Imagine it would make that accounting company's job very easy. The second is it gives you a full picture through time, as I said with my EMR example. This could give doctors a more informed basis for giving me a diagnosis or giving me some sort of medicine. They would be able to see everything that has happened to me through time. And third is it removes overhead. Now, when I put this bullet up there, I should have really included an asterisk because it does remove overhead in that as developers, our traditional implementation for tracking entities over time right now is by putting 2 columns on every one of our database tables, a modified by and a modified time column. So it removes that overhead because that stuff comes inherently with blockchain. However, there still is overhead and it still does cost money, so there's overhead of another sense. But it does remove that overhead of needing to track when entities were changed because it does that inherently for you. On the other side, we have sharing data across organizations. Blockchain allows you to inherently trust the data because you can see exactly how that data was changed from the time that it came in to the time that it left any other organization that has trusted or touched the data rather. Again, it gives you the full picture through time and it eliminates that cost that I was talking about of data translation and data mapping between different systems communicating with one another. So how would you do this? Here's where I'm going to go up the slope of enlightenment and hopefully take you up to the plateau of productivity. So blockchain itself, it may seem hard that some sort of random number is going to solve all these problems that I mentioned earlier. And the secret is it's really not. What's happening and what's doing the work is what's known as smart contracts and decentralized apps. So smart contracts allow you to exchange things of value in a secure and transparent way. These can be fired manually, like you developing on a blockchain can call them like you would any other API, or they can be fired automatically when some certain list of conditions is met. So essentially it just acts like a server. When I say that it acts like a server, it looks like a class there. It acts like a server in that it's always available. You can call, push requests to a call request from it, but it looks like a class. And what I mean by that is that it has methods and properties on it. So smart contract pros and cons. One are, the first is that autonomy equals speed and accuracy, right? We're eliminating the human element. We're saying as soon as these conditions are met, go ahead and run this this function or program, which really helps eliminate that error potential. And additionally, you get all of the blockchain benefits. You get the immutability, you get the security, you get the distributed factor of it. The negative is that the code lives forever, right? If you push a bug out there, you can make it so that it can no longer be called, but everybody can see that you once had a bug out there. Which is kind of like getting caught with egg on your face, right? Nobody wants to push a bug to production, and now that bug can be seen forever. The next is that it's hard to determine responsibility. Now in our world, this is hard to imagine, but in a world where these smart contracts were handling a lot of logic, it would be really hard to determine in a court of law who's responsible for the actions that that smart contract took. Is it the person that developed the smart contract? Is it the person that called the method on the smart contract? Or is it anybody that is running that instance of the blockchain that has that smart contract on it? Who do we prosecute in that situation? Sorry. And then the last is that physical products aren't ready. In my example with Walmart tracking beef products, they probably had IoT sensors on those like individual wrapped portions of beef, where they could track temperature and stuff like that. A lot of the devices and objects that we interact with on a day-to-day don't have IoT sensors tied to them. So as they do come online, like when you pick up like a loaf of bread at the grocery store, if that has some sort of RFID tag or something like that, as those come online, blockchain is going to become more and more popular. Right now, obviously, when you pick up a loaf of bread, it's a plastic bag, not so much wood. So here's a quick demo of how this works and some technologies that you can start going with if this stuff interests you and if you want to get going. I'm doing this demo as like this is very low barrier to entry. So anybody that's familiar with JavaScript can get going. So the first tool is an NPM package called Truffle. If you're familiar with NPM, it's just a JavaScript library, and you can just do an NPM install command, and then you're off and going. Truffle has these pre-built boxes, or like essentially like demo web apps that already interact or are set up to interact with the Ethereum instance of the blockchain, or test implementations of the Ethereum instance of the blockchain. So this is a really quick way to get going, and you actually see this in my demo shortly. The next is Ganache. This is from the same creators as Truffle, but all this does is set up a demo implementation of the Ethereum blockchain on your local computer, and it gives you 10 test accounts so that you can play around with the smart contracts that you're developing. And the last is MetaMask. MetaMask is a Chrome and Firefox plugin that helps you manage your identity on different implementations of the blockchain. This is just my app.js. I just wanted to show code. I don't know how familiar you guys are with JavaScript, like I said, but I just wanted to show that this is very reachable and achievable. It looks like any other JavaScript that you would see. This is in the smart contract programming language known as Solidity, but it looks very close to any object-oriented language that you're going to interact with. So this is a function that we're about to see. It's called give doctor access. So this is kind of like an authentication filter here, which is only the patients. And so you'll see that this is saying only the patient can call this function. And if we will send the public address of the doctor and then the doctor's name to this function. And if it's the patient that sends it, we're going to add that doctor's public key to the list of valid doctors for this patient. And then we're just going to push that doctor's name. So here's a live demo. Off to the right, you'll see Ganache. This is my test Ethereum instance running over here. Off to the left, I'm just running truffle compile, which is compiling that code that I showed down into bytecode. Next, you're going to see me run truffle migrate, which is just going to deploy that now compiled bytecode onto my local instance of the blockchain and be ready to run. And if you see, that is really small, but that just went from 0 to 6 on the current block, which means that our smart contract was deployed. All I'm doing now is running npm run dev, which if you're familiar with JavaScript, just runs your local website. So you're about to see the web app pulled up. This is what I imagine the patient dashboard kind of looking like. So you'll have blood pressure and BMI. This is MetaMask, and you'll see right now I'm logged in as the patient. This is flying by, but so this is the patient looking at their dashboard. And we're going to go ahead and try to add a doctor. So we're going to add a doctor named Dr. First. I'm going to pull this public key off of my test implementation of the blockchain and click Add Doctor. MetaMask pops up and asks us to confirm this transaction, and I'm going to go ahead and submit that transaction. Once this transaction is confirmed with that little circle, that means that this is now in my local implementation of the blockchain. So if I go ahead and refresh the browser, you'll now see that Dr. First is one of our doctors. So if I switch over and log in as Dr. First, and try to add a doctor from that, you'll see that Dr. First cannot add a doctor to this patient's list, but it can add a note because we trust doctors to add doctor's notes to our patient's dashboards. So again, we're going to submit the transaction. The transaction is going to be approved and put on the blockchain once that circle pops up. It takes a second because that's when that mining work is happening. If we refresh, we'll see the first note there on the medical notes side of the patient dashboard. That's because doctors can't execute that function. If Dr. First tries to add his bad doctor, Dr. Second, his friend, to our patient record, it's not going to work because we have that only patient filter on it. So we'll go ahead and submit this. And you'll see we get that warning block that says that this transaction failed. So I know this is a very simplified example that you can run with any language and an authentication filter, but I just did that to bring a visual to my EMR example that I used throughout. So what's next? Where can you go from here? If you want to learn more about blockchain, the Software Engineering Daily podcast, they did a month out blockchain in the month of March, I believe it was. That was super helpful. Every day they had people come on from different companies, stuff like that, to talk about what they're doing with blockchain and what it's all about. Here's some other resources. If you want to code, you can go to ethereum.org/token. It'll show you how to set up your own implementation of the blockchain and get started with your own cryptocurrency. If you have any questions, feel free to email me, brad@breckmanning.com. And that's all I have. So hopefully you're at the plateau of productivity and you can walk out of here and make a difference with blockchain. Thanks, guys. Do you have anything else?
Do you want to take questions?
Yeah,
if you have questions.
Yeah, give us your questions. Go for it.
Yeah.
I don't know how familiar you are with the encryption in blockchain, because I remember I once pulled up an article about blockchain and the first line was, since the Fermat theorem was proved in 2011, we have whatever computation cryptography that's working on blockchain. And I don't know if you have comments on that. How is that? Do you study any of those?
I haven't gotten too deep into like what specific type of cryptography they're using, or like what. Are you talking about like what hash algorithm or what cryptographic algorithm they're using?
I believe that's what the article was for, but I didn't understand the article.
Yeah, I'm not sure exactly. Yeah, I'd have to look more into that. Sorry about that. Yeah, we got one up front, then we can come.
What do you make your slide look?
This is PowerPoint.
They're super nice.
Thank you. No, I can't stand those like online ones where you like zoom in and out. Yeah.
So for that, how is, I think I'm missing a piece of like how it's applied to EMR, if records are supposed to be encrypted or like secret, whereas the ledger is like public, like how does that work?
Yeah, so you can see, so like if you look at, like if you install a client, you can see all the transactions that are happening on the blockchain, but you wouldn't be able to see like for example, if I had a node on there, you wouldn't be able to see like one Bitcoin transferred to Brett Koenig. But you would be able to see that one Bitcoin was transferred to my public key address.
Okay.
Does that make sense?
So it's based, so you can be hiding behind your phone, basically.
Yeah. Is that?
Yeah.
Any other questions? Nice. Well, if they come up, feel free to email me or grab a business card.
We'll totally put these slides online.
Yeah.
And make sure your contact info gets out there
Okay.
when you have questions. Any last questions of Brett? All right.
We've got business cards down here too,
Yeah.
so if you have Joe,
Another big round of applause. We'll take a moment to show you what's coming up at the ACM, and then you'll have a chance to talk to Brett and Amber if you want after the meeting. Get to know them a little bit better, get to know the company a little bit better.
We got fun t-shirts and bags if anyone wants to grab one.
Oh yeah. Our t-shirts are like novelty items around the IT community in Columbus, so make sure you grab one when you can.
For sure.
Okay, so a few last items before we are finished. So ACMW upcoming meetings. ACMW has an upcoming meeting on the 20th, and it's going to be on interview prep. Anything you want to add about that, Tessa? Okay, thank you. You can see acmwuc.org for more info. So ACM upcoming meetings, we have ICR Security as a guest coming in to talk about reverse engineering and cybersecurity. That is September 27th at 6:30. And October 4th, we'll have a version control, Git, and Unix workshop. Both meetings are right here in this room. How many freshmen do we have, first years do we have in here? Sweet. So Git, GitHub, version control, all that stuff is definitely something you need to know for your co-op. It's going to make your resume look super awesome. So it's definitely a skill to have. Any upperclassman will tell you that. And there will be plenty of upperclassmen here to help you out with that workshop. So I recommend you come. happening around EECS. EECS is Electrical Engineering and Computer Science Department. So I told you about ACM, ACMW, and IEEE. Their topic and date is TBA for the next meeting. But there you go. CAS Career Fair, this is super important. There's a ton of companies coming to UC on the 20th from 10 to 3. There are 60 plus companies looking for CS co-ops. So that's awesome. Make sure to take your UC ID, plenty of copies of your resume, and dress professionally. Don't wear shorts. You know, I think that's pretty obvious, but I guess we'd be surprised. Yeah, and if you're a freshman or first year, definitely go to the career fair. It's a great experience, even if you're not looking for a co-op right now. So then you'll be prepared for future career fairs and you'll know what to expect. So I very much recommend you do that. Upcoming info sessions, this is all in Slack. This is a ton of information, but there's a ton of companies coming on campus. So make sure to check out this table in Slack. And right after this, we'll have a HackCon recap talk. We had a few members go to HackCon, the conference for student hackathon organizers, and it's open to anyone interested in hackathons or Revolution UC, our student hackathon. So that'll be coming up right after this meeting wraps up. But that is it. Thank you again, Amber and Brett. That was really awesome. And thank you. Oh, Tessa.
Yeah, if you have questions about Verified Coders,
Yes.
volunteering event, feel free to come talk to me.
Yes.
Or Siley after.
Cool. Good? All right. Thank you, guys.
If anyone's interested in chatting further tomorrow, because we will not be at the career fair, so I've still got a couple open slots if anyone wants to chat here tomorrow. Or if not, take my card, email me. I'm happy to
Feel
chat.
free to chat with Amber, Brett.
Yeah.
Grab more pizza.
Yes, please take that home. Go eat.